Part A. We're first going to use the division law to collect together the logarithms on the left-hand side. So I'm going to rewrite the left-hand side as log base 2 of the x plus 1 divided by the x. We're now in a position where we've got log base 2 on both sides of the equation with nothing else involved, so I can do 2 to the power of everything on the left-hand side is equal to 2 to the power of everything on the right-hand side. These are inverse functions, so cancel out and just leave me with the x plus 1 over x. And on the right-hand side, again, these are inverse functions, so cancel out and just leave me with the 3. I can now multiply both sides by x. Take x away from both sides and divide both sides by 2. So x is 1/2 for question A. Part B. Left-hand side, the log base A of y. I'll leave that as it is. There's not a huge amount I can do with that right now. But the right-hand side, I can combine those logarithms together with the multiplication law. So we'll rewrite the right-hand side of log base A of 3 times the 2y minus 1. Now we've got log base A on both sides of the equation. I can do a to the power on the left-hand side and a to the power on the right-hand side, because those are inverse functions and they're going to cancel out. Similarly, those are inverse functions are going to cancel out. So on the left-hand side, I'll just be left with y, and on the right-hand side, I'll be left with 3 times 2y minus 1. Expand those brackets out. And solving this equation, I'll subtract the y from both sides, add the 3 to both sides, and divide by 5, and I find that y is 3/5. Question C. The left-hand side, I'm going to combine those logarithms together with the division law. So I can rewrite the left-hand side as log base 3 of the 3z plus 4 divided by the z. Right-hand side, there's not a huge amount I can do there, it's just 2. On the left-hand side, I've got 3. I've logged to the base 3. So if I did 3 to the power on the left-hand side, that would cancel that logarithm out. I would also have to do 3 to the power on the right-hand side as well, but that's okay, we can deal with that. So as I say, those are inverse functions, so they're going to cancel out. So that's just going to leave me with the 3z plus 4 over z. On the right-hand side, I've got 3 to the power 2, or 3 squared, which is 9. If I times both sides by z to get rid of that fraction, subtract 3z from both sides, and divide both sides by 6, I find that z is 2/3. Part D. Looking at the left-hand side here, I can combine those logarithms together with the division law. So I'm going to rewrite the left-hand side as log base 5 of the 4w plus 3 divided by the w minus 1. Right-hand side, not a huge amount I can do there, that's just 2. Now I can remove the log base 5, now I've got it by itself, by doing 5 to the power. These are inverse functions and cancel out. And that's just going to leave me with the 4w plus 3 over w minus 1. So we've managed to remove the logarithm. The right-hand side, I'm left with 5 to the power 2, or 5 squared, which is 25. Multiply both sides by the w minus 1 to get rid of the fraction. So we've got 25 times w is 25w, and 25 times minus 1 is minus 25. I'm now going to subtract the 4w from both sides. And I'm going to add the 25 to both sides. Divide both sides by 21. And I find that w is 28 over 21, or 4 over 3. So the important thing with all these questions is to make the logarithm the subject using the laws of logarithms so that you can then remove it by doing the base to the power of.